Today we're going to be looking at synthesis and decomposition reactions. So the main purpose here today is to predict the products. So we're going to be given the reactants, and also we always want to determine what reaction type we have. And then from there, depending on what type of synthesis or decomposition reaction, we will predict what kind of products will form. Okay, so just a review here, synthesis reactions. So synthesis creates, right? So we're going to have some reactants. So in our examples today, we're going to have two reactants. You could have some scenarios where you have more, but we are going to have two reactants. They're going to come together and create one product. Okay, and then the opposite reaction, the decomposition, right, to decompose, to break down, that's where you have one reactant and it breaks into pieces, right? So we have, here's a visual as well. Okay. All right. So from here, you're going to have these little guideline tables that you're going to use. So I'm going to provide them on any assessments. I'm not going to show you I'm not going to provide the examples on the assessments. They're just for the notes here. But you will have the type and the general equation, okay, that you can reference. Okay, same with the decomposition. Here's the type, okay, and then here's the general equation. All right, so within these guidelines here, I'm going to have M written down. M is metal, okay, so there, and NM is non-metal. All right, so let's jump into this. We have our synthesis reactions. There's three types that you have to get comfortable with. All right, there's the binary compound, so that forms, okay? So basically you have a couple elements here, and they're going to make a compound, okay? So that's what we're going to see here. And then we'll have a metal oxide with water, what happens there, and then non-metal oxide with water. So for the first one, so again, if you want to understand this as, yeah, like it's an element, okay, an element, and then it makes a compound, like that, okay? So, so what we're seeing here with our examples is, so we have our element. I know element, you're thinking, on the periodic table, we just have H on the periodic table as an element, right? But it always exists as a diatomic, right? So there's the, the Hoff wrinkle. Okay, there's these ones here. They always exist as diatomics like that. Okay, so yeah, they're in a way compounds, right? Because there's a couple atoms together, but it's an elemental compound, so they still consider to be an element because there's only one type of atom creating this diatomic. All right, so we have hydrogen and oxygen. So right away, you should be able to recognize this reaction by, oh, okay, there's a couple of elemental compounds being brought together. So in that case there, element makes a compound here, so it's going to be a synthesis reaction. So what you're going to do here is when you're trying to figure out how to write the formula for the product, so you're going to have to put hydrogen and oxygen together. So at that point, you can, treat hydrogen as a metal there, and oxygen as is the non-metal. So when you balance the charges or crisscross, you're going to get H2O. Okay. All right. Here's the next example. Calcium. It's a metal. Okay. And remember, metals just write just the symbol. You don't write a subscript. And then we have our diatomic here of oxygen, always O2, right? Hoff wrinkle. So when you combine those together, so it's an element and an element being combined together, we have calcium oxide here. So again, how are we going to write the formula? Well, we knew calcium had a 2+ charge. We know oxygen had a 2- charge, so that's how we get CaO. Okay, and then there's fluorine and aluminum. Okay, so again, diatomic metal, you don't need a subscript, but when you combine them, you're thinking about, okay, aluminum's got a 3+ charge, fluorine's got a -1 charge, so AlF3. Okay, and remember, you always write the metal first, okay? You always write the hydrogen first with acids and so forth, okay? All right, but then when you're, I guess you're combining it, yeah, so yeah, that's how you write. All right, so potassium and chlorine, okay, so same thing. We have element and element, so you combine them together, Potassium is a +1 charge, chlorine's a -1 charge, right? So it becomes KCl. All right, so there's our first example of synthesis reactions. We're trying to identify them because we see two elements being combined together, okay? So it's going to be a different story if you have compounds coming in, right? Because if you have an element and a compound, then you have single displacement. If you have a compound, that's double displacement, okay? So this is how you differentiate synthesis from the other reactions that you've been studying. Synthesis is element makes a compound. Okay, here's our next example of a synthesis reaction. If you have a metal oxide, so some sort of metal with oxygen in a compound, and you're combining it with water, you're going to undergo a reaction, a synthesis reaction. Okay, so metal oxide with water, and then what will happen is it'll form a base. So the examples that I'll provide you is that base, right, if it has, it'll have the hydroxide ion. So it will be, to keep it simple here, we're always going to have some sort of metal hydroxide ion like that, okay? All right, so because, yeah, there are other types of bases out there, but for this one here, yeah, we'll just keep it simple here. Just a metal oxide becomes, with water, becomes a metal hydroxide. Okay, so if you take a look here, we have sodium oxide and water being mixed together. They undergo a reaction. So you're going to take the metal sodium and then just put it with hydroxide here. Okay. All right. And then one thing you may notice here is that I'm not going through and balancing these. I'm just trying to keep this lesson simple, where we're just trying to show you the examples of, okay, here this element and this element combine and make this compound and so forth, okay? In the next lessons, we will mix all of the different reaction types together, and then I will want you to come up with balancing the equations on top of predicting the products, and then even write the state symbols, okay? So for today, just keep it simple. Just come up with the products and then make sure the formula is correct. Okay, because, yeah, if you don't have the correct formula, you're going to not be able to balance it, okay? All right, so here we go. We have sodium oxide and water becomes sodium hydroxide. All right, here's another example, magnesium oxide, so another metal oxide combining with water. So what will happen here is that they just combine together, synthesize, become a synthesis reaction, and the metal combines and creates hydroxide, metal hydroxide, so magnesium hydroxide, okay? So again, if you're trying to figure out how do I come up with the formula, you know you got to put a metal and the hydroxide together, right? Both of them a -1 charge, so NaOH. Magnesium has a 2+ charge, okay, and hydroxide -1, so crisscross. The 2 comes down, remember put brackets around the polyatomic, so Mg bracket, OH bracket 2. All right, last example for a synthesis reaction is a non-metal oxide with water. Okay, so again, Nm means non-metal. Okay, oxide and water being combined creates an acid. Okay, so what you're going to see here with these examples are you're just going to literally combine these together. Like if you have this many hydrogens, total up whatever many oxygens you have all together, and then the non-metal oxide. Okay, all right, so here we go. So here is sulfur dioxide. Okay, combining with water. It undergoes a synthesis reaction, so they stick right together. And then here's the formula. So see how I had 2 H's, so 8 H's, right? Because you're creating an acid here. So right, you want an acid plus whatever the non-metal is, right? And so we have the 2 H's. We have the 1 sulfur, so we have 1 sulfur. And then the oxygens, yeah, there's 3 of them, so just make it 3 over here. Okay. All right, here's the next one. Carbon dioxide and water, same thing. Stick them all together. We have 2 H's. Yep, there they are. 1 carbon. Yep, and 3 oxygens. Okay. All right, and then the next one is sulfur trioxide with water. Stick them together, H2S, 1S, and then 1, 2, 3, 4 oxygens, SO4. Okay, so that's all you do with the acids. So just kind of combine them all together, okay? Well, I guess that's what we're doing with everything. But so the main thing here is you don't have to, you know, try to do crisscross or anything like that. They're just combining together. Okay, and then here, this one here, you have to, yeah, just balance out the charges, and this one you combine as well. Okay, so now that we've seen kind of our examples here, let's try our guideline table. Let's try some examples down here. So you can stop the video and try to predict the products for these ones here using our table. So again, keep in mind that you want to get comfortable with the first column and the second column here. Those will be provided. These examples won't be here, okay? All right. So here we go, hydrogen. Okay, so I'm just converting everything to a formula. So I know hydrogen's a diatomic, chlorine's a diatomic. Okay, so right away I'm seeing an element. So I know, oh, it's a synthesis reaction. It's not going to be a double displacement or single displacement. Okay, you got element. So this is element. Remember, is the compound. So we're looking at the table here. So it's a binary compound that's going to form. So we're going to put hydrogen and chlorine together. So again, just a reminder, what do these look like as ions? Right, you have the H plus and the chlorine is negative, right? So when we actually go to combine it as a product, right, we want to charge balance or crisscross, okay? When hydrogen's by itself, it's a diatomic. When chlorine's by itself, it's a diatomic. But together, it's hydrogen chloride, okay? Or hydrochloric acid. Okay, next one, aluminum. Okay, it's a metal. We don't write a subscript. Bromine, Hofbrinkel, right? Those diatomics. Okay, so again, you identify the reaction. It is element. Oh yeah, synthesis reaction. So you're going to combine them together. So here, maybe I'll show the work on the side here. So H plus and Cl. Okay, so now we have aluminum, which is 3 plus, and bromine, that's negative 1. There we go. Okay. So we come up with the aluminum bromide compound. Okay, here's the next one. We have strontium oxide. So let's write that out. So we know strontium has a 2 plus charge, oxygen negative 2 charge, so strontium oxide, and water. Okay, so we have our, what do we have in this case here? So we have it's not an element, okay? So we're trying to look at our guideline table here, and we're seeing water. Okay, so we have a metal oxide water. So what's going to happen here? It's going to form a base, and it's going to form a metal hydroxide. Okay, so let's write that out. So if it's going to be a metal hydroxide, remember, hydroxide has a negative 1 charge, right? So we're going to combine strontium and hydroxide. So that 2 is going to come down. Charge balance, you get 2, so you need to bracket around the hydroxide. Okay, so here is a different synthesis reaction from A and B. We have a metal oxide and water. Okay, so next one, sodium. Okay, so just sodium alone is a metal. Iodine, oh, that's a halogen, that's diatomic. Okay. All right, and so again, element and element, so we're just going to combine them together. How do you do that? Well, sodium is a plus 1 charge, iodine is a negative 1 charge. Perfect, so NaI, like that. Okay, sodium iodide. All right, next one, we have, this one's calcium oxide, sorry, there we go, calcium. All right, so Ca 2 plus and oxygen 2 minus makes CaO and water. Okay, so we have a metal oxide and water. Okay, so how does that look on our table here? It should be a metal hydroxide that forms. Okay, so Ca. OH2, like that. Okay, all right. Okay, here's the next one, sulfur monoxide. So it's a non-metal here. All right, so sulfur monoxide, right? Just one of each, right? We don't write mono on sulfur. And then we have water. Okay, so what do we have here? We have a non-metal oxide with water this time. So take a look here. That's supposed to form an acid, so we just combine them together. Just kind of take all these pieces, put them together, write the H first, write the non-metal next, and oxygen after, okay? So we have 1 sulfur, 2 hydrogens, and then we have two oxygens, like that. Okay, and carbon monoxide, one carbon, one oxygen. We don't write monocarbon, just carbon. The second one we have to write mono. H2O. All right, let's combine these together. H2, okay, one carbon, two oxygens, like that. Okay, so with the non-metal oxides, just stick them all together, create that acid. Okay, so again, you will be given the first and second columns of this guideline table. You won't be given the examples, so be able to use it to come up with the correct products. Okay, here are the decomposition reactions. So these are the opposite. Okay, so before we were creating one reactant, now we're taking one, oh sorry, we're creating one product before, right? So with the synthesis reaction, we created the one product, a base, an acid, or just a compound like that. Okay, decomposition, we're going the other way around. We're starting with one reactant, and then yes, things fall to pieces here, okay? All right, so we'll look at the binary compound. So basically we have a compound and we're breaking into elements, okay? So if you see either a metal element or the diatomic elemental compounds, right, the Hofbrinkel, then yeah, that's what you're seeing, the compound go to elements. So yeah, if you have to predict the products, you just see the one reactant, right? It's going to be decomposition. But yeah, how do they break apart though? It depends. So if you have a just a binary compound, two elements like that, you're going to just break it into the elemental pieces, okay? But then you're going to get ones where there's polyatomics, right? So polyatomics means that there's more than one element clumped together as an ion. So those are going to break apart differently. So you just have to, again, identify what kind of reactant you have. So if you have a metallic carbonate, so you have a metal and a carbonate, right? So the M member is metal, NM will be non-metal. So you have a metal with the CO3 ion, carbonate ion. What's going to happen is you're going to become a metal oxide, and then the carbon dioxide gets released. Okay, so you can see here, the metal is potassium, potassium carbonate became potassium oxide with the carbon dioxide released. All right, here's the metallic hydrogen carbonates. So again, remember hydrogen carbonate, the other name that chemists use is bicarbonate, okay? So, you know, be able to identify it both ways. Okay, so I think chemists like to use bicarbonate more often, but anyway, so hydrogen carbonate, bicarbonate, same thing, okay? All right, so if we have a metal with a hydrogen carbonate here, we want to, sorry, let's get this out of here, it's not messy. All right, so we have our metal, so remember our formula is always HCO3, okay, if it's the bicarbonate or hydrogen carbonate. So if we have the metal hydrogen carbonate, we are going to break it into the metal oxide, a water, and a carbon dioxide. Okay, and I put the state symbols in there, don't stress, but again, it's good practice, right, to just kind of start recognizing things. All right, so again, metal hydroxide breaks into three pieces. So we have a metal oxide, so the sodium oxide, we have a water, and a carbon dioxide. All right, the next one is metal hydroxide. Metal hydroxide. So, okay, so like bicarbonate was an HCO3 ion. Okay, so hydroxide is a OH ion, right? So if you see a metal with a OH, what's going to happen here is it becomes a metal oxide with water. Okay, so you can see that that's like the opposite of what we saw above, right? We had metal oxide came in with water, so it became a metal hydroxide. All right, the next one is a chlorate, ClO3 with a negative one. All right, so if you see a metal with a chlorate ion, right, it's polyatomic, it's going to break into a metal chloride and oxygen is released. All right, oxyacids, remember those are the acids that have hydrogen, they have oxygen, but then they have a third element here, right? So they have a third element here. So examples are like sulfuric acid, okay, nitric acid, stuff like that. So you have hydrogen, you have the oxygen, but you also have the other third element. So if you have an oxy acid, what's going to happen here when it decomposes is that you're going to create a non-metal oxide and a water. So basically, remember how with the synthesis reactions we just stuck them together? So now you're just going to break them apart, okay? One oxygen will go to the water, and then the rest of it will have one less oxygen here, okay? So if you take a look here, see that there's here sulfuric acid, H2SO4, so it's going to decompose. So you get your water, H2O, so H2, and then one of the O's goes. That leaves 3 oxygens left for the SO3 part. Okay, all right, here's H2SO3, H2O's pops out, okay, and then that leaves one less oxygen for the SO part, SO2. All right, so see how it's SO3 becomes SO2, SO4 becomes SO3, CO3 becomes CO2, so here we go, H2O pops out, okay, so that leaves us with CO2 left in the product. Okay, all right, so I know a lot of stuff here, but remember, I'll allow, the guidelines will be there, so you can kind of use that as a framework, okay, so that just to kind of be able to help you predict the products, okay? All right, so go ahead and try the ones below, and you can start the video again. Okay, so here's the first one, barium carbonate. So again, your nomenclature should be awesome and shiny now, so if you're still struggling, keep practicing, okay? Go back to those initial worksheets from the beginning of the semester and keep practicing those, okay? All right, so I have barium carbonate, so I'm just doing the work on the side here. I know that barium is a 2+ charge, carbonate's a 2+ charge, so when they combine, they make barium carbonate like that, okay? No brackets needed because the 2 would have come down, the 2 would have been here, but then they had to cancel, so there's no brackets around the CO3. Okay, so right away you just have that, so it's one reactant, so right away you should be able to recognize that, oh, it's going to be a decomposition, okay? So from there you're going to use your little table here and go, okay, what does this look like? Oh, barium's a metal, and carbonate, oh yeah, it's going to be the second one here. So what happens here? You just follow the little general equation here. You're like, okay, metal oxides, you have to make a barium with an oxygen, right? So there'll be a place to do some work on that. So barium and oxygen have to come together. Oh, those are both 2+ charges, so or 2 charge, a +2 and a -2, right? So they cancel out. This becomes barium oxide like that, BaO. All right, what else do we need? We need a carbon dioxide to pop out. Okay. All right. So again, we're not balancing today. We are just trying to put all of our energy into predicting the product. Okay, so we have to predict the right product. We also have to come up with the correct formula. Okay. All right. Barium oxide. Yeah. Okay. Next one, zinc hydroxide. So again, come up with a formula. Zinc. Okay. Hydroxide is -1 charge. All right. So that means we need zinc, OH, brackets, 2 comes down. All right, so go to the table again. What do we have? We have a metal and a hydroxide here, okay? So what happens here? Metal hydroxide becomes a metal oxide and water, okay? So metal oxide, so oxygen again, I'll just write here. Both of them are a charge of 2, so we get zinc oxide like that. And what else pops out here? A water. Okay. All right, keep going. Sodium chlorate. So again, sodium is a +1 charge. Chlorate is a ClO3 -1. Remember, just look on the back of your periodic table for those polyatomics. Combine them. All right, both of them have a 1 charge, so NaClO3. Okay, so from here, sodium chlorate becomes, so again, you're like, one reactant, oh yeah, decomposition. So take a look here. Is there a carbonate, a metal and a carbonate? Or chlorate, my bad, chlorate, yes, there it is. What happens? It becomes a metal chloride and oxygen. So you just go Na, oh yeah, chloride, just like, just the chlorine, okay, not chlorate. The chlorate breaks apart, okay? So chlorine is a -1 charge, so yeah, NaCl, and what else pops out? An oxygen. Okay, so pay attention to the table because sometimes it's a carbon dioxide, sometimes it's the water, sometimes it's the oxygen, right, as the other product. So, All right, keep going here. Magnesium bicarbonate. So magnesium, okay, bicarbonate is HCO3 negative. All right, so you combine those. Okay, that 2 is going to come down. So this bicarbonate is going to need a bracket with that 2. Okay. All right. One reactant. We have a decomposition. All right. Do we have any bicarbonates? Okay. So right now, this is where I don't want you to freak out. You're like, I can't find a bicarbonate. I see a carbonate. Is that the same? No. It's hydrogen carbonate, remember, and bicarbonate, same thing. Okay. It's on your periodic table to say, hey, you can say hydrogen carbonate or bicarbonate. All right, so what happens here, you're going to get 3 products. We have a metal oxide, a water, and a carbon dioxide. So let's do that. Metal oxide first. Metal oxide. Okay, so MgO. What else? A water. What else? A carbon dioxide. Okay. Oops, what happened to my plus here? There. Okay. Okay, here's the next one, sulfuric acid. Okay, that's the classical name. So what was the formula? So we're like sulfur. Okay, so that's the sulfate ion. Okay, and then from here, sulfate. Okay, so remember the 8 something icky. So you're like, oh, it's the sulfate ion. Okay, so then add a hydrogen with it. And let's come up with our formula. So H2 from the sulfate becomes that, and then SO4 does not, just the 1 comes down. So, all right, no brackets. All right, sulfuric acid. All right, so we have an oxy acid. Okay, if you're trying to figure out which one we have here, we don't have a metal something. We don't have a binary compound. We have an oxy acid. We have a hydrogen, an oxygen, and a third element here. So what happens here with oxy acids? They spit out of water and then the non-metal oxide. So what you're going to have here is, you can have the water first, you have the second, whichever. So H2O gets created here, and then what's left? The SO3. Okay, so basically if we were to break them apart and then send a water out, that would leave an SO3 left for the other pieces. Okay, all right, here, let's try another one. Last one, potassium. Potassium is +1. Chloride, that's -1. Okay, so we have our ionic compound here. So you take a look, which one is it? Is it a metal chlorine? No, you don't see any. They have a chlorate, but you don't see a chlorine. It's not an oxy acid. Oh, binary compound. Okay, so what happens here? They just break into their elemental pieces. So potassium and chlorine like this, okay? So people will make the mistake. There's a slight error here. So I'm just going to give you a second to figure it out. So potassium and chlorine break and become potassium. Potassium's a metal. You don't need a subscript, but chlorine is a diatomic, so you need the 2 there. Okay? All right, so there are all of your examples of what happened to the Cl here. Sorry. Oops, sorry, the Cl there. Yeah, so those are your examples of decomposition and synthesis reactions. So again, I know there's a lot of stuff here, but being able to use the tables here to help you predict, you should be able to predict the correct products here, because otherwise without them, it's it is an overwhelming thing to do here. So again, these are just kind of like the general reactions that happen. Of course, there's always going to be an exception where this is happening instead, but yeah, overall, in most cases, this is what will happen, and then you can predict the products this way. Okay. All right, so please keep doing lots of practice with these. Again, having the table, but remember you won't have the example table, that last column there, okay? So you can kind of go, oh yeah, that's what they did there. So you have to be able to do it from the general equation. Oh yeah, some metal, oxide, and then water, and then the base comes out, okay? All right, so go and practice.